Okay, so this is going to be a quick review of the 5 questions from the quiz that you all took this past week. So they may be in a different order slightly than the order they were in when you took the quiz, but that's more just because we randomized the order. So just locate the questions. All right, so this question says, below is a picture of a stack of 2-inch by 6-inch by 10-foot boards. What is the moment of inertia of a single one of these boards if used in the plank orientation? Okay, so the most important thing to remember is that plank orientation, okay, is drawn, excuse me. Okay, so plank orientation refers to a board that's laying like a diving board or a plank, like walk the plank kind of thing. Okay, so that was the first thing, is that's plank orientation. So it's actually in the picture, it's in a plank orientation already. But 2 by 6 by 10, so 6 inches is this dimension, 2 inches is this dimension. So if we were looking at that from the end, right, we would see 2 inches and 6 inches. So basically they're asking for moment of inertia. The formula for moment of inertia is base times height cubed divided by 12. Most people who got this question wrong got it wrong because they did not draw the board that way. They drew the board in joist orientation, but it says plank orientation in the question. So if we do our givens, our base is equal to 6 inches. Our height is equal to 2 inches. And then we would basically substitute into this equation. So moment of inertia is going to be equal to 6 times 2 cubed, which is 8, divided by 12. Moment of inertia is going to be equal to 48 divided by 12. Moment of inertia is going to be 4. Okay, next question. Beam deflection can be calculated by using what important property that indicates a material's ability to resist deformation when a load is applied? Okay, so beam deflection can be calculated by using what important property that indicates a material's ability to resist deformation? Well, so the answer to that question is just moment of inertia. Okay, is moment of inertia. So that's really just a vocabulary question here. The vocabulary question, so basically, right, beam deflection is equal to force times length cubed divided by 48 modulus of elasticity times moment of inertia. So moment of inertia would have been the correct answer there. Okay, the image below represents 2 by 4 by 12 long board made of Douglas fir. It is being used in joist orientation to support a load of 1,200 pounds. Okay, so joist orientation means that the cross-sectional area is going to look like this. Means this is going to be 2, this is going to be 4. Moment of inertia is going to be equal to 2 times 4 cubed, is 64 divided by 12. So moment of inertia is 128 divided by 12, which is 10.67. Okay, so beam deflection equation is force times length. Now, previously I had told you that the length you need to deal with is the length between the supports. So you needed to use this length, but length needs to be in inches. So you needed to convert 8 feet to inches, which is 96 inches. Okay. And then you needed to go down to 48 times the modulus of elasticity, 1 million, times the moment of inertia, which is 10.67. So we should have gotten 1200 times 96. So a new numerator of 115,200 and 48 million times 10.67. So 5, 1, 2, 1, 6, 1, 2, 3, 4. And that would have given us, let's see, I did something wrong here. Okay, let's pause. Okay, so actually, sorry, this should have been 128. Pause for 1 second. Okay, sorry about that. I'm back. All right, so this was 1200 times 96 cubed. So that was where I made my mistake. I forgot to cube that. Most common mistake is doing that out of order, or the most common mistake is forgetting to convert that to inches, or the most common mistake is not using this distance. Some people used 144, which was incorrect. In my lecture video and in the practice problems, I talked about needing to use the distance between the supports because that's what's feeling the actual force. Okay, all right, so we need to do 96 cubed times 1200. One moment, 96 cubed times 1200. Okay, so gives us a 106.168320. Okay, and we're going to divide that by 5, 1, 2, 1, 6, 1, 2. And we get 2.07 inches as our deflection. So this board will basically bend this will be 2.07 inches, the amount that it bends. Okay, all right, next question. You are asked to build a deck in the back of your neighbor's house. The neighbor has purchased all of the lumber already and just needs your help in finalizing the design and executing the build. The main components of a deck that support the top boards are the joists that are below the top deck. The joists right here, okay, the joists. They're responsible for actually supporting all of the weight on top of the deck. Which piece of wood would be best used for the joist of the deck? Okay, so you had a couple of options here. The options that you actually had, if you give me 1 second. Okay, so the options that you had were these. And the first thing you should know, right, so we can cancel some of these out right off the bat. Some of the ones that we can cancel out are this one, because it's a plank, this one, because it's a plank, and this one, because it's a plank. It says in the problem that it's in joist orientation because that's the strongest. So then we have 3 here, and basically what we're trying to do is find the one that has the highest moment of inertia. So remember, moment of inertia is base times the height cubed divided by 12. So the first one here would be, right, look like this, and it would be 2 by 4. The second one here would be 2 by 6, and the last option would be 2 by 8. So the 8 cubed times 2 divided by 12 is going to be the highest moment of inertia, so this would have been your correct answer. And then the last one was basically a vocabulary question. The higher the modulus of elasticity, the more likely it will resist deformation. True. In the lecture, I said high I, right, high moment of inertia equals high resistance to deforming. Okay, All right, that'll do it for the wrap up of this.